Hey everyone, welcome back to Bioschool. This is Gayatri. In today's session, we are going to talk about the cardiac cycle. So let's start. In the last session, we have discussed action potential in heart, where we have discussed action potential in cardiac myocytes as well as in pacemaker cells. You will get the link in the description box down below and in the suggested video above. So please have a look on that video and gain the knowledge on how the action potential it takes place in the heart and what is the difference between the action potential in cardiac myocytes and pacemaker cells. Let's move to the today's session. Today's session it is the cardiac cycle. So what is the cardiac cycle? So the cardiac cycle it is the mechanical event that begins at the end of one heartbeat to the beginning of next one. For that it takes on an average 0.8 seconds. So I will make you understand the cardiac cycle in an easy way. We will discuss each of the phase where we will focus on the pressure of arterial pressure and the ventricular pressure, their difference, ventricular and arterial pressure difference, AV valves whether they are opened or closed. AV valves means the tricuspid as well as bicuspid valves. Then SLV valves means semilunar valves. Are they opened or they closed? We will discuss it in each phase of cardiac cycle. Also, we will look into what type of wave it formed in the electrocardiogram. So, let's start. So, the first phase, it is called the ventricular diastole. So, what is the meaning of diastole? Diastole means relaxation. At this time, the ventricle, it is in relaxed state. Relaxed state, that means it is filled with blood. So the question is, where from the blood that comes into ventricle? It passes the blood from through superior vena cava and inferior vena cava. It enter into the right atrium. Okay, and this blood, it is the deoxygenated blood. Similarly, the oxygenated blood through pulmonary veins, it enter into the left atrium. Then from the right atrium and the left atrium, the blood it enters into the respective ventricles. Okay, so it passed around 80% of blood that flows from each atrium to the ventricle passively. That means during that time, atrium it is not in contracted stage. 80% of blood that pass from the atrium, from right atrium to the right ventricle, also from the left atrium to the left ventricle, that is by passively through AV valves, that is tricuspid valves and bicuspid valves. As the ventricles it is in the relaxed state, so the chordae tendina that holds the AV valves to papillary muscle is loose and there are some leaks through which 80% of blood that pass from the atrium to the each ventricle, and that 80% blood it is about 105 ml. Then in the next step, SA node or the natural pacemaker cell it get depolarized and action potential is generated. Then the action potential from the right atrium it moves to the left atrium. So is the action potential generated, thereby the atrium it get depolarized. Depolarized means atrium now it get contracted. As it get contracted, so the volume it is decreased or reduced. If the volume reduced, then pressure increases. Okay, so now the atrium it has the higher pressure than the ventricles. Arterial pressure is more than the ventricular pressure. So blood it will move from the high pressure to the low pressure. So now the rest 20% of blood, okay, that is 25 ml of blood, it moves from each atrium to ventricles, okay, through atrioventricular valve. So now the atrioventricular valve it is open. If in this situation we compare the pressure of the ventricular pressure to the arterial pressure, arterial means the pressure in the pulmonary artery and systemic aorta, then the arterial pressure is higher than ventricular pressure. So as the arterial pressure is higher than the ventricular pressure, so blood cannot move from the ventricles to artery. So the semilunar valves it is closed. During this time, as the ventricle it is in the diastole, that means atrium it is in contraction phase or depolarization. When atrium it is in the depolarization state, at that time P wave it formed in the electrocardiogram. Now what amount of blood it is present in the relaxed ventricle? That is about 130 ml of blood. So the amount of blood that is present at the end of ventricular diastole is known as end diastolic volume. It is called as end diastolic volume or EDV, and it is about 130 ml. Let's go to the next phase. Next phase is isovolumetric contraction. Iso means same, volumetric means volume. So now the blood volume is same in ventricle. That means neither the blood comes into ventricles nor the blood moves out from the ventricles. So in the last step, the blood from the atrium it enters into the ventricle. As the blood it is empty in the atrium, so the pressure is 0 in the atrium, but now the pressure is higher in ventricles as compared to the arterial. Okay, ventricular pressure is higher than the arterial pressure. So if the ventricular pressure is higher than arterial pressure, blood it will try to move from the high pressure to the low pressure region, that is from the ventricles to atrium. That is prevented by AV valve. Okay, that is tricuspid valves and the bicuspid valves, because the valves they allow unidirectional blood flow. As the AV valve it get closed, then it will produce the hard sound which is known as lob. Lob it is produced when there is closure of the AV valve or atrioventricular valve, and this is the fast hard sound, and this lob sound it is longer and louder. Okay, now we will compare the ventricular pressure to arterial pressure, that is the pressure in pulmonary artery and systemic aorta. So which one has higher pressure? Obviously the pressure is higher in the arterial than ventricles. Okay, as the pressure is higher in arterial than ventricles, so blood cannot move from ventricles to pulmonary artery and systemic aorta. That means the blood volume in ventricle is maintained same, as it is not moved from ventricles to artery. So the semilunar valves that are closed, and during this phase, this ventricle it is in the systolic phase. This is the part of the ventricular systole, that is the ventricle it is in the depolarization phase. Okay, ventricle it start to contract. Okay, the cardiac myocyte, it is this arrow, it represents the cardiac myocyte. They start to contract and push the blood out from the ventricles, but here in this situation it maintains the isovolumetric contraction and blood cannot eject from the ventricles. This is the part of the ventricular systole or ventricles, they are in depolarization state, and it will form QRS wave in electrocardiogram. So let's see the next phase. The next phase is ventricular systole or the ventricular ejection phase. So in the ventricular ejection phase, what will happen? Of course, ventricular ejection means the blood which is present in the ventricle that will move out. Ventricular systole means it is in the contracted phase, and the myocardium or the cardiac myocytes they get contracted or they depolarized. Heart is in cone-shaped structure. If there is a push or contraction from the bottom, then what will happen? The blood which is present inside it, it will ooze out. As they are contracted, the volume it get smaller. As the volume gets smaller, then pressure it will be higher. Okay, pressure will be higher. Pressure will be higher than arterial. If you compare the atrium to the ventricle, then pressure in ventricle is higher. Similarly, now the pressure of ventricle is also higher than the pressure that is present in the systemic aorta and pulmonary artery. Okay, so the ventricular pressure is also higher than arterial pressure. If the ventricular pressure it is higher than the arterial pressure, so blood it will move from high pressure to low pressure. That means blood it will ejected from the ventricles, this one is the right ventricle, to pulmonary artery. Similarly, from the left ventricle to systemic aorta. Okay, that's why it is called as the ventricular ejection. So how they will move? They will move when there is opening of the semilunar valve. So here AV valve it is closed and semilunar valve it will get open. Ventricular pressure is higher than the arterial pressure, it will get open. So now the question is, what amount of blood that is ejected from ventricles to artery? That is only 70 ml of blood. How much blood it is ejected? It is 70 ml of blood. At the end diastolic volume it was 130 ml. Out of 130 ml, only 70 ml of blood it is ejected from each of the ventricle. So now what amount of blood it is left in the ventricle? That is about 60 ml blood it left. And the amount of blood that left in the ventricle at the end of systole, that is known as the end systolic volume. It is called as end systolic volume and it is 60 ml. During the ventricular ejection phase, not all the blood it is ejected out. Only 70 ml of blood that is moved out from each of the ventricles, but 60 ml of blood still remains in the ventricle. And that amount of blood that remains in the ventricle at the end of ventricular systole is known as end systolic volume, which is 60 ml. And during this phase, it will also form QRS wave in electrocardiogram. Let's see the last phase. That is isovolumetric relaxation. Same volume it is maintained. So let's see the pressure first. So now we'll compare the atrium and ventricles. So the atrium it has no blood, so it has a zero pressure, but the ventricles it has only 60 ml of blood. See, here it is full with blood, but here only 60 ml of blood is left. That is known as the end systolic volume. If we compare these two, atrium and ventricle, then the pressure it is higher in the ventricles. Now we'll compare the ventricles to the artery. Okay, pulmonary artery and systemic aorta. Is the blood that moves from the ventricles to the artery. Artery has more blood and more pressure than ventricles, right? So the arterial pressure is more than ventricular pressure. Systemic aorta, it is elastic. So when it will reach in blood, then it will expand a little bit and it will supply the blood to upper extremities of body like head and neck. But some of the blood that will try to move back into ventricles, try to move back to the ventricles. But at that time, the semilunar valve, it will get closed. If the semilunar valve it get closed, it will produce a sound. That sound is called as dub. Dub is the second heart sound. Blood it cannot enter back into the ventricles because of the presence of valves which allow the flow of blood in unidirection. And this phase, the ventricle it is in the relaxation phase or in the repolarization. When ventricle it is in the repolarization state, then it will form T wave in electrocardiogram. Hope this video is able to clear any confusion that you might have. So for understanding biology in an easy way, stay connected with me. So let's see the previous year CSIR question related to this topic. First question. For a normal heart rate, the time taken for arterial systole and diastole are AS and AD. Okay, arterial systole it is represented as AS and arterial diastole as AD second respectively. While same for the ventricular systole as VS and ventricular diastole is VD. Which of the following equation is correct? Okay, so the equation is arterial systole plus arterial diastole equal to ventricular systole plus ventricular diastole. That is option 1 is, or option A is the correct answer. So let's see the next one. The time taken for arterial systole and diastole in a normal heart rate is TAS. It is the arterial systole and this one is the arterial diastole. If ventricular systole takes TVS, ventricular systole is represented by TVS second, then calculate the ventricular diastolic time. So what is the formula? AS plus AD equal to VS plus VD. In the question it is asking about ventricular diastolic time, that is it is asking about TVD. Okay, so what will be the value of TVD? TVD is TAS plus TAD minus TVS, right? So the correct answer is option A, TAS plus TAD minus TVS. Thank you for joining me today. If you enjoyed this video, then please give a thank you for joining me today. If you enjoyed this video, then please subscribe my channel. If you enjoyed this Thank you for joining me today. If you enjoyed this video, then please subscribe my channel for more such informative videos in upcoming days in an easy way. If you have any questions, suggestion and request, then please comment down below. If you have any question, any suggestion, then please comment. If you have any question, then please put a comment down. Thank you for joining me today. Thank you for joining me today. Thank you for joining me today. If you enjoyed this video, then please subscribe my channel and do share with your friends. If you have any question, request, if you have any thank you for joining me today. If you enjoyed this video, then please subscribe my channel and do share with your friends. If you have any question, suggestion and request, then comment down below. I will get back to you as soon as possible. Thank you so much. Bye bye. See you in my next video.